Fantastic. Yes, feel free to get another drink, another snack. There's plenty there, and there will be some more as well. Welcome, everyone. So it's a great honor and a pleasure to welcome you here to the Responsible AI Soirée. It's been a very, very long planning session to get this on the road. COVID has played some tricks on us, of course, but I'm really, really happy that we can do this under these circumstances in person without having to wear masks, so we can actually network, see each other, and have a drink. So, first, a big, big thank you for all of you for showing up and being here with us tonight to look into how we can build responsible artificial intelligence. And I'm really excited about the speakers that we have for tonight. But before we go into the speakers, I want to thank each and every one of the organizers, and I know it takes a village to plan something. So Caitlin, first, thank you so much for getting us in touch. Thank you for the applause. But also Manuela Fuchs, Christina Damm from the team who have supported massively. Of course, Professor Lütke for supporting as well. And then Sophia Greulich from our side. Unfortunately, she couldn't make it tonight, but she sends her regards, and she's also excited to then see the recording afterwards, what we have produced here. But also all the supporting actors, Annette Horab, who's taking pictures, Babette, who has greeted you down in the lobby, Julia, who is here supporting me with the slides and everything, and Marcus from our tech team, who is hopefully doing a good job with the sound. So big round of applause for everyone supporting. Thank you so much, and really, really looking forward to a great evening. So what is the topic of today? So we thought we are here with the TUM Institute and us from IBM. Very naturally, we said, how can we combine research and business with the focus on responsible AI? So how can we encourage and facilitate that collaboration even further? And that will be the theme throughout the evening. You will see the different pitches from the different project teams, from the TUM side of the house and from the IBM side. And they all have one thing in common. They always have a research component and more the overall frameworks, and then also a business component to it, whether that's a company supporting it or whether it's really done with a large entity. So that's the topic for tonight, and I hope you all brought a big appetite not only for the buffet but also for interesting questions. So I want to keep this session as interactive as possible. We have plenty of microphones up here, and I will hand it to each and every one of you if you have any questions throughout the entire show. I really would love to have a discussion ongoing and afterwards in the networking session as well. So don't be afraid, raise your hand and we'll get you a microphone so we can get your questions in. So with that, I would love to kind of go through the agenda, what we have prepared for today. So we are in the midst of the welcome and the introduction. I will go into a little bit of a background on what IBM is doing in the space of trustworthy AI. So what's our point of view? And then we will have the project presentations. So we try to keep it short and snappy. And I will be looking at the time. Julia will be supporting me. We want to have 5-minute pitches, so we really get it down to the essence, and then the questions from you in the audience and from the other speakers and experts as well, of course. We will be going through them one by one, and then afterwards we have a short break, and we will start the panel discussion with everyone here from the team, and you can ask them questions as well on the topic, of course. And then afterwards, we'll have a quiet and nice evening with some smooth jazz again and some drinks. So hopefully this is a welcomed agenda. And with that, I would love to quickly jump into kind of our point of view on trustworthy AI. We have picked the audience a little bit in a sense that we don't need to start with Adam and Eve. I will not be going through what is artificial intelligence and do we need it, but I will jump right into the meat of it. I did bring, however, one study that just came out recently from the Global AI Adoption Index that is actually saying that 43% of companies that were asked are exploring AI. So that means they're looking at use cases, they're looking at projects where they can use artificial intelligence to improve some of their processes. And actually 31 have already deployed some sort of artificial intelligence throughout their business. So that means 47%, if the math adds up, are actually already in place with AI projects. And I think this is a significant survey with 5,500 IBM clients and partners around the world. And that just shows you the prevalence, right? And I thought to myself, right, how often do I come into contact with AI? And that's already one of the first problems. There's not a lot of transparency if you are actually interacting with artificial intelligence. I know from a fact that if I look at the weather forecast on my iPhone each day, that's being provided from the IBM weather company, and we use AI algorithms to predict the weather. So even there, very small example, but there's the interaction is there, and the prevalence is there as well. So how can we stop from these things happening, that we have horror scenarios like the Terminator? Unfortunately, when we go to clients and our partners, we have way too many of these images in the heads of our partners. So how do we get these images out of their heads? Because we see them in the media, it's being publicized, it's being used, and of course it's a great topic for a movie, but it's not the reality that we live in. And I think we can all agree that we need to do something to shatter those images. And I brought a quote from our former IBM president and CEO, Thomas J. Watson, who over 100 years ago, I think, made this quote, and it still rings true today. Our machines should be nothing more than tools for extending the powers of the human beings who use them. So we want to use artificial intelligence, or as we actually call it in IBM, augmented intelligence, to support human beings, right? To extend the capabilities, the things that we cannot do as well. And that is really a guiding principle for us at IBM, really ethics at the core of everything we develop. And hopefully you will see that throughout the pitches from the IBM team as well, that when we start developing, we always have this ethics question at the core. And that's also one of our frameworks that we do, right? So the purpose of AI, augmented intelligence, is to augment the human intelligence. It's not to replace humans, it's not to combat humans, but it's really to augment our capabilities. The other very strong principle that IBM says is that the data and the insights belong to the creator. So we shouldn't be using data or algorithms that we have programmed for a certain customer in other customer projects unless they give us the specific usage rights that we can do that. So this is really at the core of what we believe, and this also guides our work. So if you look out there into the marketplace, we are not ones that are going into different business models. We really stray true to being a cloud and an AI company. The last but not least, technology must be transparent and explainable. And I think that's really, really key. I just mentioned at the beginning, we are not even aware when we are interacting with technology like artificial intelligence. And unless we make it transparent and we make it explainable, we will not have the trust from society that they will actually adopt these new technologies. So I think this is really one of the key elements, and that brings us to the next big thing, is to govern the data and the AI technology, right? And these are the 5 research areas that we are strongly working in, and I'm thankful that in the keynotes that you'll see in the pitches, we have certainly most of these areas covered in one or another dimension. And last but not least, and that brings me back to the topic of today, is we need a very strong, open, and diverse ecosystem. So these are just a few examples of where IBM is working with, and I'm most proud to have the responsible AI Soirée down there as well. This is just one of the things that we do in order to really accelerate and foster that collaboration and to be able to speak about these topics and really go into research, really go into projects where we implement these types of things. So that was a very, very short introduction and a high-level overview. I want to leave it at that because we gave the challenge to our panelists to stay with 2 slides. I didn't manage to stay with 2 slides, but I just wanted to give you a brief overview on what IBM is doing. I'll pause here because you haven't paid attention to the first part, which was interactive. So, are there any questions, thoughts, comments that you would like to share? I can wait for quite some time. If not, yes, first question. I love it, the icebreaker. Green microphone is coming right to you.
Well, thank you for the very interesting introduction. I have one question because you place the relationship between AI and humans as something technology should not replace humans; it should augment them. What do you think, or what do you have in place to make sure that this relationship stays like this, and we not have like ever more intelligent technologies at some point just replacing humans because they're quote unquote better?
Yeah, so I think that's exactly where we started with the 3 bubbles. So the ethics at the core, when you think of projects, think of how what you're doing and what you're introducing into the market, how is that affecting people's lives? We actually have one of the banners when you entered was about human-friendly automation. That's one of the practices that we have here at IBM. And it's looking at if you're introducing technology, how are you introducing it and what does it actually do with people's jobs, with people's behaviors, etc. So I think it's about creating the awareness within the company, within each of the developers to say, what is happening with what I am currently developing and how is that changing? I think that's the most important one. And then, of course, we have governments in place. For example, we are part of the ethics forum. We have a board of ethics officer within our company that is looking at each of projects that AI is being introduced or other technologies are being introduced that might have an impact and look what are the ethical implications of that. And but it's actually the responsibility of each and every person within the company to keep up those standards that we define for ourselves, right? Great question. Any other questions? If not, I am really, really excited to get my 2 first keynote speakers up here. We have Oksana Boch and Ellen Homa. So welcome to the stage, and I'll hand it over to you.
All right. Hi, I'm Oksana. This is Ellen. And we're going to talk about towards an accountability framework for AI systems. That's what we've been working on for a year now. And I'm going to introduce to your motivation first. So, you know, AI is fantastic. AI is great. We can do new things that are really crazy with it now. But AI can also go really wrong. I'm just going to give you a few keywords and examples are going to pop in your head. Gender bias, racism, all that kind of things. And so when this happens, who should be accountable? At this point in time, I cannot tell you. So that's why we're researching on this. And you can see we're not the only ones thinking about this question of who should be accountable for what, according to whom, all that. In 2018, you see a big peak of interest in this topic. That's also the year the high-level experts group, which is an EU commission, came up with the 7 key points for a trustworthy AI, right? So they were in the time. And you see it's going a bit down since then, but it's still quite up. And so we're quite sure that this is a good thing, a good question to ask. But now, if you go to scientists directly, you can see that maybe on the social science, the ethical science, all of that, will be really interested in it. But scientists, unfortunately, are not up to date about this, and I'm not going to say it's their fault. I think you'll see here that when we ask Earth observation scientists, have you ever read a paper on ethics, they're going to tell you yes, and we're fully aware of what it's supposed to do, but only 40%. And then 90% of them will tell you, but why for? What for? It's not applicable. And that's when we try to come in and translate what are the ethical principles and all those great ideas into something practical that you can use in your everyday work.
Yeah, exactly. So this transition from, let's say, all the theoretical thoughts about it, and now translate them to actually something really practical is what we aim in our project. And what we want to do is to create an accountability framework. Well, that's really practical. And this, for that, we take a risk-based approach, because by that we can build off of what has been validated already, what has been evaluated, so kind of what's already out there. And you can see here that the risk-based approach, so our accountability framework, is built off of risk assessment, risk management, and responsibility assessment methodologies. So we kind of can make use of what's already out there. And how do we exactly do it? Well, kind of to give you a bit of a context of what we plan to do, we identified these 4 major questions that we want to target and also try to answer in our accountability framework. And that's at first, who is accountable? Well, this question might seem fairly easy. It's very short, and it might kind of, it seems very easy. But at the same time, we all know that it's not when it comes to AI. Because as in particular, when AI makes its own decisions and predictions and so on, the question of who is actually accountable and who should be responsible is not so obvious as we might think. Second question is, for what is someone accountable and towards whom? So that's actually the concrete responsibilities or obligations that come up. So the actual duties that need to be fulfilled. And that's where our risk-based approach also comes in, because here we argue that we can define the responsibilities based on the risks, because you need to be accountable for the damages or the risks that your AI can cause. And then in step 3, this is, let's say, the heart of the accountability framework. So that's where it's basically, well, the steps that you need to take to ensure compliance with your responsibilities and, in a way, live up to your obligations. And then question 4 more aims at the satisfactory explanation of all of that. So basically, that's the second component of accountability. Well, we have our first component, which is what are our responsibilities and who is actually responsible for that. There is also a second component, which is ensuring compliance, but also proving compliance with your responsibilities. So actually prove to third parties that you have lived up to your responsibilities. Yeah, so that's a very, very brief overview of our project, and I guess you have many questions to all the details now. So I would just like to end before we go to our Q&A session with one, let's say, quote from our colleagues from the Oxford Internet Institute. And I think this sums up quite well what we aim with our project on a more broader level. And this is: AI ethics research has long focused on the what, but now we need to continue, and that's what we want to do with our project by targeting the how.
Fantastic. So I already have the first question, so maybe I'll do the icebreaker now. So in your research, have you already started validating with companies on how this can be implemented? Actually, yes. So we do this whole project with an industry partner, which is located next to you, so it's Fujitsu, so it's quite near here. So we're always talking to them and always discussing with them if it's very applicable. But at the same time, we're also having multiple workshops with partners from industry, with partners from research, civil society, so more stakeholders also. And yeah, maybe to do some marketing here as well. Our next workshop is in June, so you can reach out to us here or emails if you want to join that as well. Very cool. Thank you so much. Any questions? Yes, Francis.
Thank you very much, Wolfgang. Yeah, I love this quote at the end, and I guess this is something that you've had to think about quite a lot. when anyone begins assessing how you can build some kind of practice or some kind of overarching process, in essence, the how, right? This is a daunting task, and this is, in particular, when we think about AI ethics and explainability and trustworthiness, this is an incredibly abstract simulation and requires a bit of mental gymnastics. And so I'm just curious, how did you get started on this process? What was the seed for that?
A lot of hours of just sitting, looking at a blank table or blank thing on the wall and just say, okay, where do we start? But yeah, then, I mean, the risk-based approach started to make sense quite quickly, I think, because, you know, we've been, reading a lot of things, obviously, to get a lay of the land. And that's something that comes up a lot when you talk about EU future maybe regulations or even just approach from the high-level experts group. In the EU ecosystem anyway, it makes a lot of sense. So I think that's where we started. We're like, well, there is risks, therefore there is a problem. And if there is a problem, there is someone who needs to be accountable.
Merci.
Fantastic. Any other questions? Yes. Lovely.
Thanks. Super interesting research. Thanks so much for your quick introduction. I was wondering, when you talk about the how, is it going to be a framework, a process, the goal of your research, or is it also going to be maybe an approach for a technical solution on how to gain that, reach that goal?
Yeah, so the framework is more, let's say, from a theoretical perspective, because what we mean is not a technical framework, but there are definitely technical aspects to that. So, for example, we mentioned that we use risk management, and risk management can have several approaches. So you can have proactive risk management strategies, which then more target kind of avoiding the problem from the very first, let's say, from the very beginning. And that's definitely something technical. I mean, you developed it yourself, the IBM AI Fairness 360 suite. That's exactly kind of what can go in our framework, can be used through our framework as a tool to go for risk management.
Thanks.
Yes, another question. And I love that you're also looking at IBM products and frameworks.
Of course. Also, thanks from my side for the interesting pitch. I was wondering, because you say risk-based approach, and that seems to immediately ring the bell to the AI Act. You already mentioned the European ecosystem, and I was wondering, how close is your risk-based approach to what the European Commission is proposing, or are you working on something completely different?
That's a really good question. I actually expected that, so I'm very happy that it came up.
Yeah, I'm going to say close, but not that close, if we can say. We're still, you know, we're trying to build something new and something maybe more complete. I don't want to throw any shade to anyone here. So it's a great approach that they're proposing, but we want to do something maybe more, towards organizational, really for the companies, something more graspable.
Exactly.
Yeah.
And actually the two, so our approach and the AI Act, I think, really complement each other, because what the AI Act is asking for is actually risk assessment tools and risk management tools. So that's exactly what we're proposing here also with our accountability framework, that you kind of can use our accountability framework if it's developed in the end and everything to live up to we're back at the responsibilities that the AI Act poses on you.
Yeah. Thanks for passing the mic.
Yeah. Great pitch. I really love the idea. It already inspired me thinking about different examples. And with that, my question on whether you really think about it kind of on a two-sided way, meaning that some principles, some risk management on a company side, but also on the software side, because quite often this is kind of comes as a toolbox that then will be used, for instance, by small business to do some evaluation, and then it will reduce some biases. And the small business does not have a power to spend time or human resources to do anything. And so it looks like what you develop should be also sitting both with the box, and then depending on how it's further used with the company as well. So I don't know whether you already thought about that.
Yeah, actually we have. The toolbox thing is something I think we've started quite early on to think, well, we're not going to develop tools for every issue that exists, because we can't do it, right? So we've been starting to think about compiling risk management approaches or tools or references, and that's what you can call a toolbox in the end, right? If we give you a list of where to look if you have an issue.
Yeah, sounds like it could be kind of a list of those standard tests we usually perform with our analysis, like, perform this, historical bias, gender bias,
exactly.
kind of things.
And maybe, the OECD as well has been working on that kind of thing, so we're not reinventing the wheel either. We're going to go look at what they do and implement it as well.
Yeah, great idea.
Awesome questions. Thank you so much. I think this was a lovely pitch. A big round of applause for you two.
Thanks.
I know you will be here networking afterwards, so and you'll be back on stage for the panel. So thank you very much for that first pitch. And with that, we are coming from the tomb back to IBM, and it's my pleasure to introduce Michael Fössing. He's also responsible for our partnership with the KIT, which he will be hopefully talking about as well in a bit. Stage is yours.
Okay, yeah, thank you very much. So maybe I continue with that point. I think the underlying theme of today is that research on AI ethics and how we use those systems kind of like requires bridging the gap between research and industry. And I actually am allowed to do that. So I'm a data scientist at IBM, but I'm allowed to use 50% of my time as a postdoctoral researcher at the KIT. And today I'm presenting part of our research, but we kind of like, part of my job is take that ideas into IBM, spread them around, and ensure that we, what we do research on, we also sell to our customer, because it makes a lot of sense. So I would like to talk about human AI collaboration today. That's my PhD topic, which I finished last year. And before I talk about that, I want to talk about how people used to develop AI systems in the past. And I think that picture kind of like illustrates it. I think in the past, we built systems trying to replace human capabilities. And it was always a question, are we already good enough to replace a certain capability? And once we are good enough, we use that AI system instead of the human. And I think from that, a lot of those early fears in future of work kind of arose, because people were questioning, like, why am I helping you build those systems if those are supposed to replace me eventually? And as Wolfgang said, there is some middle ground there, right? And IBM calls it intelligence augmentation or augmented intelligence. And I think that's kind of like the gray area in between, right? Now we're not trying to replace humans anymore, but what are we trying to do there, right? And I think there are different kind of like styles of collaboration, let's call it that. And I think the oldest one, and I think on the slide it's called human intelligence augmentation. And when you look at the year dates of the sources, that's kind of like where it all started, right? Word editors, all the basic stuff that help humans still be in charge, but do their task a little faster, a little better, a little more, with a little more ingenuity, right? And that's where we started, right? But we moved on from there, right? And in the last few years, another field emerged, and let's call that artificial intelligence augmentation. Now it's the other way around, right? In the past, AI systems were helping us. Now we are helping AI systems. And one example might be self-driving cars, right? Who labels that data? People did, we did, right? A car wasn't able to detect street signs right away, right? They needed labeled data, and humans provided that information, right? So another way of how humans and AI are kind of like augmenting each other, right? But we do research on, we call it human AI collaboration. Hybrid augmentation is another word for that. I think what we're trying to achieve is how can humans and AI collaborate on equal footing, right? Like, as we would be collaborating as humans, how do we enable that with an AI system, right? You need to share your reasoning. I need to trust that you're actually telling me what you're trying to accomplish, right? A lot of the stuff we know from human-human collaboration kind of transfers to those systems. But additional questions arise, right? What's different, right? What's different between collaborating with the humans and with an AI system? And we do a bunch of research on that, and I have actually one project I will show you later where we do that with the construction industry. But I think the general idea applies to a lot of issues, right? We should aim for not building AI systems that replace humans, but that collaborate with humans, ideally on equal footing. And how we do that, I think, is still open for a lot of research. I have a few examples. I already mentioned the street sign one. I think some of you might be familiar with that. That's when you edit photos on your phone, right? Who has done that? Hopefully most. Yes, okay. So I think you could start just doing it yourself, right? Moving the levers, making it a little brighter, fixing up the colors. But there's also an option where you can ask the AI to do it for you, right? But it's not a final decision, right? You can still tweak it a little further. Maybe the AI didn't do a perfect job, right? And I think that's a perfect example for human AI collaboration, right? You're not outsourcing the perfect picture to an AI, but you're getting some help to get the initial better picture started, and you can still tweak it to your liking at the end. And now we're trying to take that concept to industry partners, right? A lot of the research we do at KIT is always with industry partners, and kind of like by accident, we started working with the construction industry. So I have no background there, but for the last 2 years, we've been working with construction companies, architects, and we try to take what we do research on and apply it in that new context, right? And that's one of the examples people face in the construction industry, right? The one with the text marker, right? When you get construction plans from architects, it's generally in an analog format. There are no unified standards. So when you want to do construct the building now, people start counting windows. How many light switches do I need? How many light fixtures, right? There's actually people doing that. And I don't think anyone would be unhappy if that was automated, right? So let's think about how can we use AI to solve that problem, right? Obviously, computer vision task, right? We can kind of like try to train an AI to detect those symbols, right? Light switches, fixtures, stuff like that, right? But I think as with most cases, AIs are not perfect, right? And if you want to construct a building, you probably need perfect, right? You don't need a few windows less, right? It has to be exact. So the first solution we built, we tried to automate it fully, but quickly realized that's not the way to go. And then we kind of like switched back to human AI collaboration. How can we kind of like solve that problem, but not by using an AI alone, but by kind of like engineering and designing that type of collaboration? So on the right side, you will see a few examples where kind of like responsibility and agency is kind of like getting bounced around between the AI and the human user, right? And it starts by what kind of icons do I want to detect, right? And we figured out like those are not standardized either, surprise, right? So a light switch is not a standardized icon. Different architectural offices produce different symbols, right? So you can't use like an AI off the shelf. You probably have to kind of like train your own system, right? So the first thing we did was we used computer vision and OCR, optical character recognition, to kind of like detect that area on a construction plan where all the examples are provided, right? And we use that to give the human kind of the option to kind of like configure and personalize the AI system. So maybe you don't want to detect all the symbols, right? That's probably a pretty difficult task, but maybe you just want to do light switches and windows, for example, right? So now you can just select those icons, and we used optical character recognition to already get those labels as well, right? Because they're on the plan. And now it bounces back to the AI, right? Now we have detected the icons we want to use, and the AI is automatically training itself by creating synthetic data, and it works for all icons, right? You can just like train it on general backgrounds, and that's how the AI learns to detect those icons. But it's not perfect, so what do? We bounce it back to the human and present the results and kind of like estimate the uncertainty associated with each prediction, right? And our final prototype looks like that. So you can see, I have to read it myself, those are smoke detectors, but the AI is smart enough to kind of like group them up. The green areas kind of like communicates the certainty of the AI system. And it's really easy for the human to go over those predictions and say, oh, well, that one's correct, but maybe this one wasn't correct, right? It's really easy for the human to give that kind of like final polishing to make the system work. Great example of human AI collaboration. And we actually have another example. So you might say, well, the architectural plan is really simple, right? Why not standardize the file format right now? You don't have to detect those icons. But some of our partners are now using those robot dogs to walk through construction sites, right? And the same thing applies in the 3D, in the real world, right? Did I put all the windows in? Is there already paint on the walls? Stuff like that. And I think usually there's one robot here in the IBM Center, not this week, right?
Yeah, exactly. He's right now in Berlin at our Think event. Augment, but once you come back next time, he'll be here and we can see what he does in real life.
Yeah, you have to visit again.
Exactly. Thank you so much, Michael.
You're welcome.
Very, very insightful and very illustrative. Any questions, comments? Yes, already some up here. I'll start in the back. Ladies first.
Yeah, so it was great to see an actual use case. I wanted to ask, because you said that you also work actually with the customers to implement it in the industry, have you faced any pushback from the industry? Because they are like, if I am paying to train this AI, why can't it do all the jobs? And why do I still have to participate in this process when I could have saved so much time without it? Like, what's the plus point there? Yeah, marginal benefits, like saving time, but they still need to give input. So did you face any pushback about that?
Yeah, I think that a lot of stuff plays into that, right? I think in our case, part of the problem was you need a perfect solution, right? You don't need an AI system that's 95% accurate. You need that 100%. And I think in a lot of cases, like AI systems are just not as good as industry partners accept. So I always think it's like a really easy sell to tell them, well, the AI is doing the 50% of cases that are really easy. Why don't you do the other 50%? And now you just save 50% of your money, right? And I think that makes it a pretty easy sell. And on top, I don't think it's a task any of our customers were happy to keep, right? No one likes doing that, right? There's no one that's eager to do that job. I think that's true for our case. We've done a lot of other industry projects. And I think in those cases, we usually try to work with industry experts, right? I think that's a task everybody can do, right? Mark icons. But usually we work on tasks where you actually need that expert knowledge. And then it gets even more interesting, right? Like, what is the AI contributing that the expert can't do himself? And like, what is the edge the expert still has? And then it gets really interesting regarding that kind of like deep collaboration on equal footing, right? I think that's an easier example. We have other cases where collaboration makes even more sense. Yeah.
Thanks.
Yeah, thank you very much. It was really interesting. I'm curious about the metrics. So at the beginning, you said that you designed the system without the human, right? And do you have, what was the performance without the human? What was maybe the human level performance, and what was the combination of both intelligence?
That's actually a really good question. I don't know the exact numbers, but we ask our industry partners to actually do the labeling manually, and we actually compared it afterwards. So by using the systems, they were more accurate and they were able to do it way faster, right? Just by the sheer fact, I think our system, I don't know exact numbers, I'm just guessing, but I think 95% of those icons are really easy to detect. But sometimes there's kind of like overlap of different icons. And in those cases, the AI starts to struggle. And then it's really easy for a human to correct.
Okay, thanks.
Thank you very much, Michael. Very, very interesting project. Fantastic job of illustrating it. Thanks. All right, we are quickly switching topics. We are moving away from human-AI collaboration. We are going into autonomous driving, the next two projects we have. And I welcome to the stage Franziska Posler and Max Geislinger. Stage is yours.
So welcome, everybody. Today, is it working? Yeah. I will present together with my colleague Maximilian Geislinger about one of our projects, of our research projects called Andre Autonomous Driving Ethics. And to give you a little bit background to the project, so the project is hosted and funded by the Institute for Ethics in Artificial Intelligence at TUM. And how the projects at the Institute usually work, or always work, is that you have at least two cooperation partners from different fields and expertise. So also in our case, we have on the one hand, the chair of automotive engineering with Professor Lienkamp and Maximilian Geislinger. And then on the other hand, we have the chair of business ethics with Professor Lüttke and me as a researcher. And therefore also our research question is directly in the intersection between engineering and ethics, which is, how can we implement ethical decision-making into the trajectory planning of autonomous vehicles? And to answer that question,
our approach that we adopt is in line with applied ethics. So what we do is we kind of look into the literature, into philosophy and ethics, and try to assess or identify theories that we can use that informs the decision-making of autonomous vehicles. And when we scanned the literature, we encountered kind of 3 pillars that guides our whole project in the entire endeavor. So first of all, what we found out is actually the theories that we can find from philosophy and ethics are good, but what is very important, which goes in line with the first presentation we had, we need risk management. Because when you go into traffic scenarios, traffic is nothing like the postulated trolley problem where it's about certain life and death decisions. It's instead about collision probability, about estimated harm, so it's about uncertainty. So this is the first pillar of our research. Second, what is close to our approach is, and what we've seen throughout the research is that contemporary research start to highlight the importance of having integrated approaches. So no single theory is sufficient to meet all the social, legal, moral, and functional requirements that should inform autonomous vehicles. So this is key to our approach as well. And then lastly, what is very important is actually a very nice and beneficial insight that we gained. Every theory, or most of the theories from philosophy and ethics, can actually be turned into code. And that's what Maximilian is going to show you now. And we're also going to show you why it's important to do so.
So thank you. So we've heard that in some cases it might not be enough to just consider ethics during the development of algorithms, but we also have to think about how can we integrate ethics into the algorithms. And this is exactly the case in autonomous driving, where we will have algorithms that were that take tasks that were formerly the preserve of humans. Like in autonomous driving, we're facing with decision making. And this is why we come up with an approach for the decision making of autonomous driving that considers ethical theories. So why is this important? Imagine you want to buy an autonomous vehicle. And in that case, more than 50% of you would buy the vehicle that would protect yourself at any cost. At least this is what a study says. And this kind of selfish algorithm would go on the costs of vulnerable road users, such as pedestrians or cyclists. And this is why we started to think about how can we distribute risks fair. So how should we distribute these risks? And therefore, we developed a framework that allows for risk quantification. Risk is two-dimensional. It's a probability and an estimated outcome. And we created an algorithm that actively distributes these risks. And therefore, we integrated theories from philosophers like Bantam or Rawls into our algorithm and came with our idea what should constitute a fair algorithm. We evaluated it empirically in a simulation on more than 2,000 scenarios. And we saw 2 things. The first thing is considering risk in autonomous driving is beneficial for everyone. And the second thing is that we saw moving from selfish algorithms to our ethical or fair algorithms slightly increases the risk of the ego vehicle, like the vehicle with the passenger in, but drastically reduces the risk on vulnerable road users. And this is something that's important to us and also for the ethics committees, like in the European Union or in Germany. And our next step, therefore, will be, so we developed this ethical software, which we claim is one of the first in line with the recommendations from the EU and applicable to all kinds of traffic situations. And we will put that software open source in a few months. We will also try to guide some practical recommendations. Therefore, we are in contact with CCAM, which is an initiative of the EU Commission, or AI for People. And we're also looking for exchange with the public. So, for example, you see us here standing at the IEAI Mobility, because at the end, what is fairness? And we think that we might need a consensus in society about it. And this is what we're going to do, preparing questions, what can we ask, and come back to our algorithms with these implications from society. So thank you very much.
Wow, that's, at least for me, that's amazing that we're already that far ahead in having an algorithm that can use those risks and balance them. I see there's already first question, so over to you.
The first time. Okay, one question that I have is, you said you created this kind of probabilities based on literature, right? So, and I'm wondering if you take a look to Western literature, I think some people have a different understanding of fairness than in other cultures, right? How did you mitigate the bias that you maybe have when you do this research and focusing only on a specific culture environment where you get out what is the term of fairness, right?
I mean, I can start to answer that question. I think Professor Lütke put it once quite nicely in a meeting that we had, because you know about the moral machine experiment, where they ask individuals about their preferences, whether someone should be sacrificed because of a personal characteristic or not. And then in our meeting, we pitched our approach, and Professor Lütke said quite nicely, it's not the moral machine experiment, it's the ethical machine experiment, what we're doing, because we are coming from theory and from ethics and not from morals in that sense. But also, maybe if I could now switch to the backup slides.
Sure.
Wait, maybe here, perfect. So this is actually the underlying approach that, or one of the ideas of the underlying approach that is based, that is the baseline for the simulation that Maximilian ran. So this is the ethics part in a sense, and then here you can see, for example, W, which is encountered for like a weighting, and this weighting we actually want to assess in the future by asking individuals, and I think here will be differences and different preferences depending on the culture as well. But what we also want to say is whatever comes out in these studies, you shouldn't take for granted and as a face value, so you shouldn't implement them one-on-one, because as philosophers already said in the past, what is doesn't like determine an ought. So.
Okay, thank you very much.
Fantastic. I see plenty of questions over here. I think you were first, so over to you.
Great presentation. I think very interesting topic. And my question was that you spoke about distribution of risk, and now I see there is equal distribution of risk. Like, is that the distribution that you're looking at, where you divide it sort of 50-50 or 25-25, or is it more equitable in terms of distributing the risk between, say, a pedestrian or someone like a passenger in the car?
So what we found is that one principle alone is definitely not enough. So like distributing risk by only one principle, I could tell you cases for any principle where you would say, oh, that doesn't feel right, just. And so what we come up is like we add up multiple principles, and one of them is the equality principle, as you said, and the equality principle strives for equal distribution. But we combine it also with a principle which is called utilitarianism, like we want to minimize the overall risk. And the third principle here is, and we've added also a responsibility principle to that, is the Maximin Principle, which accounts for a separate consideration of harm and probability. Because so far we summarize risk as the product of probability and harm. And the Maximin Principle accounts for just that by trying to minimize the greatest possible harm, no matter at what probability. And so these are principles that we know from literature, from philosophers, and we looked at several cases and asked ourselves, so is this principle applicable to our case? And if yes, so we integrated it in our framework, and at the end we have these weights that we want to take out of studies, which makes the final decision.
I know there are a lot of questions that are already in the audience, but I think we are at time, so we need to move on. But I think you're here as well afterwards, and you can definitely ask them a question, because I will definitely ask a little bit more on how you did this, how you came about it. Fantastic work. Thank you so much. Staying in the theme of autonomous driving, we have our own Francis Pausland here, and he will be talking about how he implemented a recommendation in a project that he did with Fortis. So over to you.
Thank you. And I have to say, I was about to stand up when Wolfgang called out Franziska Pausler, because I was thinking Francis Paulsen is quite similar. So hi, yeah, just to sort of set the scene a little bit, I did not come from the TUM side of things, so this will be a lot less theoretical, a little bit more showy, but I hope it's something that you can enjoy nonetheless. So it says here enablement session, because you're all about to be enabled and what this is, but just briefly, this was not just myself, but I had some wonderful, wonderful people who have been working with me over this. So when we talk about XAI, as we call it in IBM, we could call it AIX, but that's an operating system, so we don't do that. What we're looking at is how can we look at trajectory prediction, or rather lane change prediction in a vehicle, and then also how we can actually explain why those lane changes happened and what were the ultimate reasons underneath that actually led the AI in this case to that conclusion. And so, of course, as you know, responsible AI is one of the most discussed requirements and use cases, and this demo will highlight what it's all about. And of course, we try to implement this lane change system, and we want to explore this sort of state-of-the-art research. So this was done last year. We'll see if it's still state-of-the-art enough or not, but we will find out. And as it says, the goal really is to build a demo to offer a peek into what autonomous driving looks like. So let's switch over to my laptop. Hopefully this is all going to work just the way it did before. It looks like it is. In just a second. There we go. So we have here a little bit of an IBM XAI experience. And I just want to set, before I go too far in, I'm just going to quickly set the scene. We created a distributed system that actually pushes predictions to the user or multiple users in real time, based entirely out of real-time streaming data from a digital twin. And in this case, the digital twin is a stretch of Autobahn just by Garching, so halfway between here and the airport. And together, what we managed to do is actually achieve the following. I'm going to explain the next screen in just a second, because it's quite intense. Just let me wait for it to, there we go. Oh. And here we go. So what the hell just happened? We have here, we've actually tried to implement an actual driver perspective. Now, normally I would go through all the different things that you can see here. First and foremost, you can see that we're in a car and we are moving along the road. That much at least should be very obvious. Down here, we've got a little bit of a speedometer, but that's not the part that's interesting. The part I actually want to focus your attention on are this bit in the middle and also this bit on the right. It's a bit difficult for you to see here, but it actually says switch to left lane, and now it's saying continue straight. These are predictions that we're getting from our system in real time. You'll notice that most of the time our prediction is just to continue straight. And if you think about it, this makes a lot of sense because we're on an Autobahn. We're not going to be going left and right, are we? And then the next thing I want to draw your attention to is what these things are down here. These are our most impactful reasons. And these come from vehicles, sometimes further away like they are now, but also closer, that basically impact our prediction. And the way that this works is we actually use something called LIME, where we basically sample the prediction surface, and what we do is we, one by one, remove each one of these features. So the features in this case go from V0 to V6. This is each one of the 6 surrounding cars. And by sequentially removing these features and looking at how that impacts the prediction, we can then understand how it impacted that prediction in the first place. And so that is what we attempted to do. And so that is really all I wanted to talk about in a nutshell. The only other thing I wanted to hint on at this point is there's a question here. If someone showed you this, you wouldn't have a hope in hell of knowing what's going on, would you? And that's because AI explainability touches on a rather abstract form of explainability. So Marcus, we can switch it back now. Before I finish what I want, before I finish my little spiel, I just wanted to touch on this one thing. We've got a lot of work to do in terms of how a user interacts with an explainable AI. We are using AI to tackle incredibly complex topics, incredibly complex data sets, things that humans would never be able to explain. And so there's a real challenge. How do we define the interface between these potentially very complex explanations and humans. And of course, that's something that we realized after we did this UI was something that we could also work on. So that's a little bit of some forethought for me and possibly for you guys. And I would like to say thank you and welcome any questions.
It was so well explained.
I knew this was going to happen. So if I totally understand if I mean it was a demo, it wasn't fully theoretical.
Yeah.
Maybe not a question, but maybe a comment, because I really liked the presentation of your demo, and I was wondering when I heard the things before that you can maybe combine this, right? If you are doing this kind of probabilities, what is harm, what is not harm, and when we would integrate it in this nice setup where you maybe see when the car is turning or switching the lane would be interesting to see, and this could be also something that looks cool for as a showcase.
Absolutely. I would expand on this and say, I think with AI explainability, we can go further than just visuals. We could perhaps even look at things like haptic feedback, touch, sound is another one. Maybe we could have integrated a system into a car that actually gave you sonic feedback to tell you the impact of a certain vehicle based on your prediction, for example. So this is another example of how we could branch the scope out of how we choose to interface with explainable AIs in the future.
That sounds really messy, having those sounds in the car. Yeah. Next question.
Thanks. I bring the question that I didn't have a chance to ask earlier. Also kind of great demo, great project. So how about bringing to next level and also look into communication or coordination between those type of platforms that might be sitting on different cars so that you also improve your predictability. If I can communicate with the cars in front of me and they already kind of see that there is, for instance, a collision, then it's a chain reaction and kind of we're doing much better.
So that's actually that's a very interesting point you've just highlighted. And it's something that I was really thinking about a lot. How can cars be aware of just more than the first or the second car in front? This is actually a very, very unique point about our demo because there is no computer vision involved at all from the vehicle point of view. This digital twin actually looks at, the entire set of all of the vehicles going. So theoretically, with the right expertise, we could really calculate the most perfect path than having individual vehicles that just had computer vision by themselves. I think this is something that Providencia would like to realize in maybe the medium term, is that rather than just having, in this case, 1 kilometer stretch of track or 2, we are really looking at offloading all of that computational power from a vehicle and actually establishing these sort of autonomous lanes where vehicles can interact with that kind of edge cloud protocol in a standardized way. And when you get to that point, you've really turned the whole sort of autonomous driving theme on its head as we see it today. And I think this could be a really interesting topic to discover. It's also very, very relevant, not just in an Autobahn type setting, but also in closed systems as well. How can we really optimize warehouses? How can we optimize factories? And so there's also a very strong Industry 4.0 element to this as well, and how we optimize manufacturing that way.
Good pitch coming from the HMI. Thank you very much.
Yeah, I was in Hanover yesterday.
We are staying in this theme of explainability, and we are staying with IBM as well. I welcome to the stage Jan Mikolan, and he will be talking about AI explainability in stamp recognition. Over to you, Jan.
Exactly. Thank you very much. So this is actually a real-world project that I'm showing you today. For sure, I cannot show you the real client data. It's more or less fake data sets, but I think you get what it's all about. So I started with the term, a picture is worth 1,000 words. So we are using explainability for this project in order to provide the human feedback that we can actually create a human-in-the-loop decision support system. But before I jump into the solution, I would set the scene here so that you get an idea what was the use case actually about. So actually, we or IBM was requested by by the public sector from a government agency to develop an AI-based validation check for documents. So you have to imagine sometimes you have different objects on a document, like a stamp, could be also signatures, and these agencies have to check it. Is it maybe fake or is it authentic? So, and as you can imagine, when you deploy such systems in real life, this could have a huge impact of our society, right? When the AI is missing some predictions in the wrong way or is predicting things in the wrong way, it could have a major impact of our society. And this is why this point is really important, that we try to minimize any other error here. And one question before I jump into the solution, maybe a question to you. What do you think? How many AI applications can you improve when you at the human level? So we hear today lots of things that we want to bring together, human and AI. What do you think in a percentage? What is your guess? Good answer. Other answers? No? Huh? Okay, I will show you. So this is actually a study conducted by McKinsey, and it's really 90%. So, and this is what we wanted to use here. So we wanted to bring together the human and the AI. We wanted to use explainability to provide feedback to the end user, and then he can work with this AI. So here are some examples. How did we manage to implement the AI explainability part? So as you can see on the left side, this is all artificial data. You see an authentic stamp. You see we have some other algorithms which crop the stamps from a document. And then we are doing a classification plus an explainability component. And what you can see that the AI explainability component was able to detect that the shape of the country, this fake country, is maybe a little bit fishy. And by doing this, we developed actually a human-in-the-loop system where the user can actually accept or reject the AI assessment. And at the end, we want to develop an active learning approach for this so that the end user can retrain the AI. And this is also interesting because we used this kind of thing also for signatures, handwritten signatures. And as you can see here, this is also an artificial data set that also here the red pixels highlight the parts of the image which looks fishy for the algorithm. One last thing, I hope it works, it's a GIF, yeah. So what you see, explainability really depends on the audience, right? So as what you have seen before, this was for the domain experts who are working daily with this kind of stamps. But for the supervisors of these processes, we have developed something like this. This is actually the TensorFlow board, And what we have done here is that we show actually the supervisor how well the AI performs. So what we can see here later on, that we have two clusters. And this is another example where we used a COVID data set. And now you will see that we used here some artificial data set for showcasing this. But at the end, we used this kind of tensor board to show the client, for example, okay, these are images that works pretty well with our algorithm. And for example, these are images, it's really not good, we have to improve it. So I want to highlight here that we have actually two explainability parts implemented. First was the local explainability, and the second one was more or less a global explainability. Here you can see red and blue. These are actually two classes. Okay, I was really fast because I didn't check it if I'm on time. So thank you very much, and I'm now looking for your questions.
Thank you very much, Jan. Always great to see examples that are already implemented with the client. My first question would be, how was it perceived when you implemented that solution? So what was kind of the feedback from the client?
Actually, the feedback at the beginning when we started this project, you can imagine if you work in the public sector, everyone is scared about AI. So that this AI replace you. So the first thing that every IBM consultant is telling you, try to shape it as decision support system, right? And then when we showcased the first explainability parts, the domain expert, but also the supervisors of these processes were quite happy with the AI. And for this thing, I was at the beginning really skeptical because I thought, okay, when I'm showing this a supervisor, maybe he will not get how the AI works. And I was pretty surprised that he really well understood how the AI works and what does it mean, because I explained him. And this was really amazing to see. And he was saying that this was his first time that he understood how an AI algorithm works and how he splits these clusters. So yeah, at the beginning, he was quite skeptical, but at the end, it worked out.
Great, awesome. Any other questions, comments? Yes.
Thank you for such a nice use case of AI. When you were designing this algorithm or particular use case, have you thought of the consequences it could take when it goes into the society, and what kind of consequences you thought, if yes?
Okay, Wolfgang said at the beginning that we have at IBM really strict rules for this, right? So when you do project like this, or an extreme case like face detection, when you start this kind of project, you have to do an AI assessment. So you have to speak with colleagues from US in order to showcase, hey, this is the approach, this is the technical approach. And there are lots of different distinguished engineers who are saying, okay, this is a project that we can do, or this is a project that we cannot do from an ethical point of view. And one thing behind this is that the AI assessment said, okay, you can only design this kind of system when a human is in the loop.
Awesome. Thank you so much, Jan. Definitely want to hear more about this as well. I know we showcase it in our lab as well, but I've already learned something here as well. Thank you so much, Jan.
Thank you.
All right, our final panelists, very much looking forward to this one because I haven't understood what even the title meant, so really looking forward to it. We have Charlotte Heid and Charlotte Unruh on human-centered algorithmic scheduling. So, stage is yours.
Thanks so much. Okay, so I'm Charlotte and this is Charlotte. So you're bound to get the names right in the Q&A. Right. Over the last years, digitalization industry has really accelerated. So we have robots in the factories. We have smart glasses and tablets in warehouses. We have sensors and we have tags that are attached to goods that are also worn by workers. And now these digital gadgets, they collect data. They collect lots of data. That could be data that reveals a worker's location. It could be data that reveals their pace of work, their error rate maybe, their posture, their fitness perhaps, their tiredness maybe, their motivation. So with all this data available, how can we respect the privacy of workers? When managers use algorithms to make database decisions, how can we ensure that they are fair? And are new ways to track performance, is that just another way of undermining the autonomy of workers? So these questions are not just technical, right? They are social questions, political questions, ethical questions, and they are questions that we are trying to address in our research.
So let's have a closer look to our project solution and the algorithm that we are dealing with. We are developing a shift scheduling system, what you can see in the middle of the slide. As input data, we use the data, how many employees we want to schedule to how many jobs or tasks.
And we use the preferences of employees to be human-centered and to ensure that not only not performance data is used, but we simply ask people, what job do you like? What do you like about working with certain colleagues, or do you rather like sitting all day or running around or driving around? And these preferences we take as input data. Then we also take, of course, the available jobs as input data. And then we assign the employees based on the preferences onto the available jobs with an AI matching algorithm that is customizable for companies in scales from SMEs, so small companies, until large companies with many workers and also many constraints that they bring with. And then we get a schedule out of the system, which should be a proposal for the managers in production. And they can then, like you said before, in the human in the loop approach, they can reject or take the schedule and apply it, and then the people work based on the schedule that we propose. And in the end, we also have the possibility to get employee feedback. So just ask the people, how did you like your schedule today? What was great about it? What did you not like? And we could include this also then in a feedback loop into the input data. But if you don't want to give us feedback as worker, you don't have to. And about the questions that you said before, how can the autonomy at work then be maintained? Our system is developed very participatory, so we already include employees now in the development phase and in the design, but also later in the implementation and the use. We always want to use feedback of employers. And from our point of view, the worker autonomy is then mentioned by self-service applications. So it could be, for example, an app or used on a tablet, and everyone has the possibility to decide what data do I feed into the system. How can the privacy of workers be respected? We explicitly do not use any performance measurement data, but we ask the people what preferences do you have, and we ask them to give it us in questionnaires. And how can we ensure fairness in algorithmic decision making? We want to be transparent, of course, and we also want to show the criteria that we use in our shift scheduling to show the people what is the fair aspect in our system. Yeah, that's basically it, and I'm looking forward, or we are looking forward to questions.
Fantastic. Also another use case that I haven't thought about that AI could definitely support. Any questions? Oh, yes, great. We'll start in the middle again.
Yeah, so great use case. Just had one question, maybe a little bit naive, but so what is, so how do you train your matching algorithm? In the sense, you have these preferences, but how do you know what is the right solution?
So we use the preferences as input, and then use it as decision support system. So it gives us proposals, and we always let it check with the manager. So what would the manager, like normally the old way, suppose as schedule, and what gives the system out? And then we can do like a checkup. Is it a good proposal of our system or not? And this is kind of the training data. And also what we plan to do is the feedback loop. This is also kind of training data, because the employees give feedback, it was a good schedule or it was a bad schedule.
So just a follow-up question, if I am allowed. So you said that you compare with the schedules created by managers, but have you thought about, or do you already do take the feedback from employees for that schedule of these, or whether this schedule that the manager actually created initially, were they happy with it? Because you're comparing that as the ground truth, as far as I understand.
Yeah,
right?
it's a good question, because we are not sure when to integrate the employee feedback. Would it be smarter to integrate the feedback right after everyone gets the schedule, and like in, I don't know, Friday evening for the next week? Or is it better to ask the feedback after everyone worked, and maybe other factors came inside, that someone had a bad week, and also only because he had a bad day, he says, oh, it was not a good schedule.
Yeah,
So
I guess it's not such a simple answer, but just was
it's
curious
still,
about
still
it.
open, yeah, but great thought.
Yeah, thanks.
Yeah, all the way in the back. All good.
Hey, so I really like the idea, but I thought if you already take into account side conditions, like when I think about my agile software development team, they already do it by themselves. They only pick the work they like to do. But this results in, let's say, Bob always driving the packages around, and now Bob is on sick leave, and no one knows how to drive the vehicle. So do you also take into account, let's say, conditions under which the matching algorithm makes a schedule?
So you mean like qualifications of people?
Yeah, or for example, that employees have to perform certain jobs at least X times a month or something to keep their skills up to level?
Yeah, that's basically one of our ideas, that we, at the one hand, enhance people to do more jobs, or to be able to do more jobs, so that we don't have only John doing the packaging. And it's also an idea of us to to develop skills in the system, that if I want to, I don't know, get another qualification, then I get jobs that enhance me, or that allow me to get this qualification.
Awesome. Thank you so much, both Charlottes. All right, and with that, I need to do a little bit of housekeeping and throw some microphones away, because we're at the part of our panel discussion. And I love that we already have such an active discussion going on. So please keep coming with questions, so I don't have to actually invent all the questions myself. So first, I would love to invite Professor Lütke to stage, and my IBM colleagues are already helping me. Very nice. All right, so we have our 5 panelists almost ready. All right. So I said we are in the theme of collaboration between research and companies. And I think the first question that I have is, how do you select partners from the industry when you have projects that has to do with explainable AI? Professor Lütke.
Okay, that was supposed to be the easy question.
Exactly.
First of all, actually, let me say thank you very much for organizing this wonderful event here, and thank you all for being here, especially after such a long time of being virtual. Anyway, how do we select partners?
Yes.
Well, as I like to say, our institute is not a traditional research institute. I mean, of course, we're doing research, but it's not just a traditional hierarchical top-down institute. I hope the researchers here can confirm that that's the case. Hopefully. No, but what we are doing is, we are in all our projects. Okay, we are acting as a platform for collaboration between academia, industry, civil society, and politics. And we are especially, I mean, we get approached by partners, by possible partners from industry, who are recognizing that whatever they are developing, whatever systems they are developing, there are a lot of problems they need to solve that are not purely technical ones, but they are recognizing that those problems are to a great deal ethical ones or governance ones. And that can be big companies, it can be small companies, can be startups. We have a lot of startups in this area in particular. And whenever we find a worthwhile subject, hopefully also one that has not been covered too much yet, and for what, of course, we cannot do it without funding, so we need, of course, more funding for those projects. Then we really like to go ahead but we always need then, as Franziska has maintained, we need to have this interdisciplinary collaboration. I think this has been throughout our event today become very clear that we need this collaboration between the technical side and the non-technical side.
Couldn't agree more. I think the interdisciplinary, that's where really the focus lies. Ellen, you mentioned that you're working together with Fujitsu. How did that partnership came about?
Well, how it came about, that's probably Professor Lütke can answer that question better than me. But yeah, how it kind of started was very, very great. So we had many meetings and talked about the project together, and also, let's say, co-developed the project. And also, as I mentioned before, we're having multiple workshops, multiple meetings with them also to get their feedback, always in the loop to just grow together and make this project or the outcome of the project highly practical and also useful for them and other companies.
Maybe just to add one or two words about that. Like IBM, Fujitsu was one of the companies who started to recognize very early on that there are a lot of ethical questions to be solved in the development of these systems, and so they had been interested in that, but they needed to have the input from the ethics side, which they did not have before. They did not have that in-house, and you can't just do AI ethics purely in-house, I would say. You always need some external partners to collaborate with, and that's what happened here as well.
Couldn't agree more. So maybe the next question then is, what are the biggest benefits of these cross research and business partnerships? Jan, you are co-leading the partnership with Fortis here in the house. What would you say are the biggest benefits of that partnership?
So I think the biggest advantage is that you can bring state-of-the-art machine learning algorithms, applications really on the street. I mean, that you can really integrate it in your business and then really achieve great things. So especially in this Fortis cooperation, we are doing this here in Munich. So the companies come to the center and we can co-create actually this kind of innovations. And the biggest thing is that you can really leverage. I mean, if you take a look to our collaboration, we have researchers from US, from Switzerland, and all this knowledge from these people you can get sometimes for free as a company to do great things.
Awesome. Maybe the same question to you, Michael, as you're really part of the KIT partnership. Where do you see the biggest benefits?
I think at least for speaking from a university perspective, right? I think a university is a great place for companies to kind of like meet on neutral ground, right?
Yeah.
So we always collaborate with companies one-on-one, but we kind of like, as an additional benefit, allow our partners to kind of like collaborate among each other, right?
Yeah.
For example, we organize meetups on Industry 4.0, Explainable AI, stuff like that. And people from Bosch show up, from Trelleborg, from different companies who wouldn't naturally talk with each other, and they can bounce back ideas among each other, right? I think that's the first big benefit, and I think the second big benefit of universities is that so many ideas get shared among each other, right?
Yeah.
For example, in our group, we run a big design thinking program, right? Which is not necessarily has to do anything with AI projects, right? But I think a lot about that stuff is human-centered. AI kind of requires you to go out to talk with people, right? Otherwise, if you build an AI system without talking to an actual user, how is that supposed to work, right? And I think that's still a new idea, right? The people that like building AI systems are not necessarily the people that like to go out to talk with customers or end users, right?
Yeah.
But you need to do that to build human-centered AI systems, right? And
absolutely.
Where should you get that inspiration from, right? When you're just hanging around with other computer scientists, right? They don't tell you, well, did you talk with an end user? They ask, how is the model fit? How are your metrics? And did you try that optimization, right? That's the stuff they care about, right?
Yeah.
But it's part of the puzzle, right? And
Maybe the question to the academia side of the house, where would you say are the biggest benefits?
Yeah, I mean, I only can also agree on what was said earlier, that the benefits are reciprocal. So you have, on the one hand, we can co-create and co-educate each other, I think. So on the university side, if a company has an issue or a new concept that comes up, like responsible AI or explainable AI, or in our case, what does an ethical or fair risk distribution mean? They can come to us and we can kind of provide a profound understanding of what in the theory it would maybe mean, and give a more profound understanding of the definition itself, I think. Then also, I saw that you're offering a lot of certifications, so about bias in machine learning and things like these. And I mean, at our chair, we offer a lot of ethics, AI ethics seminars, so we could add to that as well. And then on the other hand, what was mentioned before is that business, on the other hand, can inform us or indicate about the key challenges that matter in practice, and also stress test kind of our approaches and our frameworks, whether they are usable in practice at all. And I think one other aspect, which was a little bit in line to this neutral ground, is what Maximilian and I encountered, that maybe we as academia can have the freedom to think more outside the box. And what I mean by that is we encountered this patent by Google in 2015 who described for their vehicles that risk distribution should be minimized, or the risk should be minimized for the passengers of the vehicle, which makes sense because they want to sell their vehicles and they need to focus on the customer. But then we kind of can challenge that idea and be like, okay, we need to focus also on the other society who would be attached.
I love that. I think it's just summarizing, it's giving different perspectives, right? Yeah, absolutely. Yeah, Michael.
And I think there's another benefit for companies, right? A lot of the partners we collaborate with, I think they come to us with problems they have that are maybe too challenging to try in their daily business, right? Who's going to be in charge? What if it fails, right? But it's really easy to try out stuff in that neutral university setting. Maybe just give it to a bunch of students, see where they end up with it, and then you can actually use it afterwards, right? Maybe they end up with ideas you didn't even consider, right? And I think that's an example from our design thinking background, right? Which has nothing to do with AI per se, but we did a project with a customer and we worked with the IT department, and there were certain questions that we were not allowed to ask, right? They told us beforehand, you probably shouldn't ask that, right? But we were, it's like 4 years ago, and we still went out and talked with people and asked those questions. At the end, everybody agreed, well, we probably should have asked those questions earlier, but people in that company, that was just a culture. There's stuff you don't talk about, right?
Why are we not doing it more? So what are the biggest blockers you're encountering if you are reaching out to businesses, and then if we are reaching out to academia?
Maybe I think that one of the biggest blocker, or maybe not one of the, but definitely one of them, is a closed mindset. So since you have multiple actors in the field, from research, from the industry and so on, and also the more people that work together in a team, probably also it's very interdisciplinary, so that's what you mentioned before. And then when you have a closed mindset and kind of only focus on your point of view and not get the other direction's perspective, right? I think that can be one major blocker, but at the same time, I think mindset can also be a very great accelerator or enabler, because once you have an open mindset and look at what the others do, are open for collaboration and also interdisciplinary approaches, and I think that can actually, enable something.
I think one of the problems can also be different cultures. Different cultures among, let's say, industry or certain companies in academia, in particular in Germany, I would say. Maybe in Munich less than elsewhere, I would say. I mean, we have created quite a good network, or how do you say? A culture within the region to improve this. But I mean, we are not where other regions in the globe are. Let's say Silicon Valley is the obvious example, but there are others as well. I mean, also in the UK, but in other countries as well, where you see much more direct collaboration between academia and industry and other partners as well. But this is something I am missing a lot. I was just a month ago, 2 months ago, at the new World AI Festival in Cannes, France, which is a completely new format, and there you see quite a different culture of approaching this. Both there were academic partners present, there were a lot of industry partners, and there was also within the general public that was present. There was also a different culture of optimism, I would say, of optimism with regard to technology, a bit different than here.
I like to hear that. Any other comments?
So I have a little bit a different perspective on the topic because, I experienced this a couple of times with clients that it's quite hard to convince them for this kind of research opportunities, even when it's free, totally free, right? And one major blocker for me, at least, is that companies, at least in Germany or in the DACH region, are scared to invest these resources, right? Even when it's only not money, even if it's things like, I give you free domain experts, they're scared about this. And there should be a shift in their thinking about how they can actually implement AI, because if you take a look, everyone is doing collaboration, right? It's impossible that you can be an AI leader without collaboration in my perspective. And this is something I hope that we can create the feeling or shifting the thinking of some of our clients towards the benefits and not of the risks and the resources that they have to invest. And this is maybe, as you mentioned, a culture thing that should be shifted in the near future.
And I think it has a lot to do with what's incentivized on both sides, right? When you come, for example, from academic, and I think we have a little sampling bias here, right? All the groups here, we already collaborate with industry partners, but I think 99% of researchers don't care about that at all, right? If you want to publish in high journals...
Might be a high number.
If you want to publish in high journals, you probably don't get much benefit from saying, I went out and I tried it out with a company, right? There's few journals that appreciate that. And on the flip side, in industry, right, publishing papers is not that rewarded if you're not in a research position, right? And I think both sides kind of like need to move a little closer to each other. And I think in the US, that's happening a lot more, right? There's professorships that's sponsored by companies. It's starting to happen in Germany, but I think the US is way ahead on that kind of like close collaboration between research and industry. But I think it's starting in Germany. I think it takes a few more years, I would say, maybe 5, 6, 7.
Hopefully.
But I think it's coming.
Let's have some optimism on that. I personally actually had a problem more contractually wise. So IBM legal said we cannot agree to the terms and conditions of TUM, and we couldn't get it through. So, I mean, there are also these type of blockers, at least what I've experienced in the past.
Yeah, so this is actually quite interesting thing. From my perspective, sometimes in this collaboration, it's not clear who's the owner of the code, who's the owner of the data.
Absolutely.
And sometimes we are doing a collaboration and nobody has a clue who is actually the owner.
We had the same problem just recently in a project, research project with many partners. We had to set up. There were so many legal questions that need to be resolved. So at some point, I didn't believe that we would get it solved, but I mean, eventually it was solved. I think it's also, there is a challenge here for the legal people, actually. They should think more of themselves as kind of enablers, not blockers.
Couldn't agree more.
And I think it starts even further, right? We have a lot of companies that would like to work with our students, right? But KIT legal department says, so if the students produce results, who owns those results, right? And are you not abusing students by letting them work for companies? We would say to them, well, that's what they're supposed to learn, right? They want to join those companies, they probably should start earlier collaborating with them, but That's not what's done in academic teaching, right?
Yeah, yeah. So I want to switch topics quickly and just ask, what areas within responsible AI do you see are much more prevalent now than it was maybe 2 or 5 years ago? And where do you see the research kind of heading? Open question to anyone.
I think a lot of like research in machine learning, they used to focus on those standardized open source data sets, right? And that's good for if you do stuff with social media, with language translation, text classification, right? Those are like those big challenges where there are big open source data sets, right? But when we work with, for example, BASF, right, or Trumpf, they have tiny, tiny data sets, and all the stuff that works really well on the big data sets is really hard to transfer to those small data sets. And I think there are solutions, but I think the awareness is starting to grow, right? There's data-centric machine learning, which is currently emerging, right? That focus on how can you use little data, how can you use the limited resources of your employees at the right time, right? Can they label some data? Can they label the correct data? And I think that's becoming really important, especially at that intersection of working with companies and transferring research results to practice. Yeah.
Yeah, I think so too. So I think the direction is heading into applied ethics. So we as social scientists or ethicists don't want to be the devil's advocates anymore, or the police telling you no, you're not allowed to do that and not allowed to do that. We want to offer, and what research is going, like I have the personal feeling that research is more and more going into the direction of offering solutions actually. Also, we have 2 postdoctoral researchers here who created an integrity index. So they're trying to make ethics measurable. And I think that's the direction that is going to be very fruitful in the future.
And I want to add maybe a different perspective as well. Right now, I can really think about lots of people are trying to attack, for example, AI models. And this is an upcoming topic which is quite important. And what we discussed also last time, which is a really interesting question, if you train a model on private data or data that is actually from any people, you can actually re-engineer the data from the model. And how do you deal with this kind of topic? So I think there are upcoming a lot of legal questions that we didn't face. So I'm quite skeptical about self-driving cars, etc., things like this. If you take a look how people can attack these kind of models, even if you manipulate some kind of images for a car, then the car opens the doors. I have seen these kind of things for Tesla. So I don't know how the researcher will provide here solutions.
Yeah. But speaking more generally, I think what we have seen in the past years since AI ethics basically started in 2018. I think you put up the slide, or Oksana, Ellen, you had this slide, how it shifted and how it changed the direction, and was very interesting to see from me, because I did not yet look at the details, that it eventually into 2020, what was it, 20, the last year that you had, the private sector, the interest of ethics in the private sector had grown rapidly with regard to the others. And that is, I think, the most interesting part. The demand for ethics, it's coming from the private sector. I think this has, to my knowledge, not in any area where ethics was relevant in the past has that been the case. The demand is coming from there, and not just from some academics who are sitting at the ivory towers and saying, well, you should think about these ethics. No, it's coming, it's really from the people who are actually developing the technology, and that's quite interesting.
I mean, one example, IBM stopping facial recognition because we said, unless we are governed on it, we will not sell the technology anymore. So absolutely. Any questions from the audience? If not, I know we are already way over time. Francis, can I ask the last question?
This might come off as being extremely ignorant, and if it is, I apologize. It's just something that I've just kind of been thinking about over the evening. We've talked a lot about particularly AI ethics and what a fair AI is. But are there edge cases where this could just catastrophically fail? Because ultimately what we're talking about is some form of oversight, right? Whether it's human oversight or perhaps it's some sort of artificial oversight. But yeah, is there a scenario where this could catastrophically fail, and what would that look like?
Do you mean a case where AI could fail? So this German is a super-GAU of the worst event that could happen with AI.
Essentially, that's where I'm getting to. We talk about, we want to use more AI because it's fair and because it's ethical. But actually, what if it turns out that there are edge cases where actually we haven't done our numbers right? And what would that look like?
I mean, I have an example of what such an edge case would be, because in our approach, we're kind of providing a solution of how you could integrate ethics into the decision-making of the autonomous vehicle. We not at the moment want to make the normative stance that this should be integrated one-on-one into every autonomous vehicle on the street. But what the challenge is in general is that we implicitly integrate values or ethics into code that shapes the outcomes for the whole society, and we're not really aware of it, at least not the general public, I guess. And I think that is a very problem in general, that we have norms that implicitly flow from the technology to society, shapes us without us knowing about it. And just on a general level, I think that that is an issue.
I mean, I would take the case of face detection, because I think the answer for this is not quite clear, because everyone has a different kind of opinion about face detection. So for example, I was seeing a case where people said they are not doing face detection because they said, okay, we have, for example, 2 images, there's a person on, but they're calculating only a score of similarity. Is it face detection? Quite hard to see, because the AI doesn't give you the name of the person, but is saying the person on this picture is the same person than this image. And this is quite interesting questions, right? It's not so easy all the time to say face detection we do not implement, because what is actually face detection? And this was a real world example, because I was facing this in IBM, that we had an assessment for this kind of thing, where it was really not clear, is it face detection or image similarity recognition, something like that.
All right, fantastic. So thank you very, very much to all the panelists here for your insights and your guidance. And I think we have all well-deserved some food and hopefully some great discussions with all of you. So thank you very much for being here. Thank you. And enjoy the rest of the evening. So let's play some smooth jazz.